Welcome back, everyone, and Assalamu alaikum. Thanks for joining again. And today we're going to talk about Power BI, episode 2. Welcome to the Data Dialogue with Talha Khan, your new favorite data guy. And Data Dialogue is a blog that I'm working on to send you free newsletters every week and upload some amazing blogs that you can refer to for training and whatnot. Anyways, let's begin. Let's start, and let's not waste any time. So I just try to recap what we did in the previous session, so we can understand some basic concepts or some main concepts, and then also these concepts will be used in the future. If you want to talk about data modeling, databases, all of that, these concepts will be used. So the only thing that I want to revise is cardinality, which is relationships. So we talked about one-to-one and one-to-many and many-to-one. I just want to revise that and just help you explain what one-to-one means and what many-to-many means. So let's say we have two tables. We have customers and we have orders. So in customers, we have four entries. We have Aragon, Arathon. Arathon is father name. Jack Sparrow, Darth Vader, and John Wick. And then we have the orders table where we have these orders placed by the customer. So you can see we have order ID, which is unique. Here, the customer ID is unique. It has to be unique. This ID will always be unique. It will not be null. It will never have duplicates because this is the primary key. Similarly, for orders table, we have unique order IDs. And then we have order dates. And then we have customer ID to tell us which customer had purchased this order on this date. For example, you can see that we have customer ID. One is Aragon. So we know that Aragon made three purchases, right? One was on 1st of Jan, then on 29th of Jan, and then 2nd of February. So now we know that this person can be linked, this one customer can be linked to three different orders, right? So this one unique customer can have multiple orders. So what kind of relationship is that? This is one to many. One, two, and three. There are three purchases. There could be 100 or there could be just one, but there's a possibility that we have multiple purchases from the same customer. And this is the diagram, or let's say the representation we have for showing one-to-many relationships. Now, if we can also talk about this in terms of many-to-one. So for example, we can say many orders can or multiple orders can be placed by one customer. So if you go from this direction to this direction, we can call it many-to-one. I hope this is clear since we're only revising this. And then I'd also like to talk about one-to-one relationship. So let's say we have this passport table where we have passport information, first name, last name, and country. So we have Cristiano Ronaldo, see, and then we have Black Panther from Wakanda. Wakanda share is this. We have Virat Kohli, and then we have Imran Khan. Well, let's hope Imran Khan stays. Anyways, then let's just divide this into two tables in passport and person. So we just want to have the passport information in one table and the person information in another table. Now you can look at these keys here, these primary keys, these passport IDs, which are unique. They just exist once in this table and once in this table. So the relationship is one to one. You cannot have two unique IDs or two passport IDs in this table, the same passport IDs, or have multiple of them in the same table. Only one Cristiano Ronaldo can exist in this table, and this person, Ronaldo, can only have one passport ID in this table. So this kind of relationship is called one to one. I hope this is clear. Now, before we move forward, there's one very important concept that I want to talk about because this is what we'll do in Power BI today as well. Is the concept of joins. Now, this is concept which will be extensively used if you're working on SQL, on databases, data warehouses, Power BI. You can even use Excel to perform joins. So there's so much applications of this. And basically, what join is, let's say, oh man, my photo is always here. How do I remove this? Yeah. So join is used to combine rows from two or more tables based on a common column between them. Now there needs to be a common column, a common attribute or a common field between these two tables for us to be able to join them. Now let us consider two different tables, right? Let's say we have, wait, I think I'm just moving ahead. Let me take a step back. Let me tell you what kind of joins we have. We have four kind of joins. So we have left join, We have right join, we have inner join, and we have outer join. We also have self join, but we won't talk about that. It is used on some cases, but it's not extensively used. So, what is left join? In left join, we talk about, let's talk in terms of tables, right? We have two tables, a left table and a right table. So in left join, all the records are returned from the left table, whatever is there in the left table. So in the previous example, we talked about, let's say, Cristiano Ronaldo, Virat Kohli, Imran Khan, and etc. So all these people will be returned. It means that whenever you run this query, whenever you try to left join, whatever is there in the left table, that will always stay there. And then it will try to see the match records from the right table. Now you would be confused and you would be thinking, what's a left table? What's a right table? In simple terms, whatever you type in your query first, that's the left table. What you type after, that's the right table. So the first table and the second table, let's talk in these terms, right? What's the right join again is similarly like just like left join. It returns all the records from the right table and only the matching records from the left table. Inner join, well, it only returns the common values from both. So unlike left and the right join, it does not return everything from the left or everything from the right. It only looks at the common values that exist in both the tables and returns that. By return, I mean it gives you that value. So when you write a query, you press enter, a result is returned. So in coding terminology, we use the word return when we say something can be seen or is shown or it's a result of your query, your expression, your code. So we say it's returned, right? So just understand these terms. It will make everything for you much easier. Then we have full outer join. So in full join, all the records from the left, all the records from the right are returned whether or not there's anything in common. So this is entirely the opposite of inner join. In inner join, you only look at the common values. In outer join, you look at anything or everything that there is in both the tables or in multiple tables and you return everything. Let me explain that to you with examples. And I think from this you might have understood that the only difference in all these joins is whether or not what to include. What's included from what table, that's the only difference in all these joins. It's very simple. It's no rocket science. It's just plain logic. So let's take an example of employees table and a department table to explain left join. So let's say we have, say, 5 employees. We have John, Sarah, Bob, Charlie, and Alice. And then we have department IDs. So we have 4 departments. We have HR, sales, IT, and finance. You can see we have department IDs. There's 1, there's 2, there's 3. You may see 4 and 5 are missing. I've removed them only for the sake of explanation. So we have 1, 2, 3, 4, 5 are missing. Then we have 6. Here we have 1, 2, 3, 4, 5. These are the unique IDs, which are the primary keys. No, there's no person other than Sarah who would have the number 2. So these are unique. And then we are referring the department ID. So we know that John belongs to HR, Sarah belongs to sales, Bob belongs to IT, Charlie belongs to I don't know what because it's not here. So we don't know what department Charlie belongs to because it does not exist in the department table. Alice has just been hired and she has not been assigned a department, so that's why it's null. Let's just think of it that way. So now what happens in left join? We said that it returns everything from the left table, matching records from the right table. Life table, wow. Matching records from the right table. So this is the left table. You see, these are all the records in the left table: John, Sarah, Bob, Charlie, and Alice. This is not Bob Marley, by the way. And then on the right table, it will only return matching records. So let's have a look at this. For John, it's returning HR. For Sarah, department ID2 is returning sales. For Bob, ID3, we know ID3 is IT, it's returning IT. For Charlie, it says ID4. ID4 does not exist, so it returns null. Null means empty or blank. There's nothing that can link Charlie to a department because it says 4 and 4 does not exist in the table. Then we have Alice. So since there's null value over here, which means Alice does not have a department, and of course that's a null, right? So you see everything from the left table has been returned and only the matching from the right table has been returned. Now let's go and talk about the right join. We take the same example. So now in right join, what happens is everything from the right table is returned and only matching from the left. What it means is, so look at this. So we have everything from the right table. We have HR, sales, IT, and finance. And we can only return matching records from the left table. So if you look at this, for HR, department ID 1, here you can see it's John. So John. For sales, ID 2, Sarah has ID 2, so it's Sarah. For IT, it's Bob. You can see Bob. For finance, it says 6. And there's no customer or no employee, sorry, there's no employee in this table that has department ID 6, right? Because it does not exist in this table. So it's a null. So it's trying to find everything that's related. Now, I talked about the most important thing. There should be a common column between two tables. What's that common column? That's the department ID. It exists in both the tables, right? That's the only way you can link two tables or anything ever. Something needs to be common. So department ID is here, department ID is here. This is the common thing between these two. So that's why we are only looking at department IDs and then returning the names in both the cases. So I hope this is clear. Everything from the right and only matching from the left. Then we talk about inner join. We said inner join only returns the common things in both the tables. So now look at this. Common things in both the table. There's three things common. 1, 2, 3. 1, 2, and 3. 4 is in this table, does not exist in this table. 6 exists in this table, but not exists in this table. So we'll ignore 6, which is finance. We'll ignore 4, which is who's Charlie. So now we're only left with John, Sarah, and Bob. And you can see here John, Sarah, and Bob, HR, sales, and IT, because these are the things based on department IDs. These are the only common fields or common values or records between these two tables. Now the outer join. Outer join doesn't care much. It doesn't care if it's in the right table. It doesn't care if it's in the left table. It will just return everything. It will show you everything. That sounds wrong, but it will return everything, not show you everything. So for example, you see all the values we have here: John, Sarah, Bob, Charlie, Alice. You can see them here. And then this is the result of the auto join. So all the values of the department table will be here. So let's walk one by one. We know John belongs to department 1, which is HR. Sarah belongs to department 2, which is sales. Bob belongs to 3, which is IT. Charlie belongs to 4. Now 4 does not exist here, so it's null. Alice belongs to null, of course, so again it will be null. And then null belongs to finance. I don't know how that's possible. 1, 2, 3, 4, 5, 6. There's a yeah, sorry, my bad. Null does not belong to finance. It's because they have taken finance from the right hand side, right? So we said everything from the right and everything from the left. So they have taken finance, all the departments from the right side. Now, when we take finance and we look at number 6, there's no one with the ID number 6 in this table. So it's returning everything from the right, everything from the left, regardless if they exist in either of the tables. The only condition is that there should be a common column between these. I hope this makes sense. If not, we can come back to this later. So now I'll just move to Power BI. This is what we did in the last session. I've just made a few changes. I'll go to the important part, which is the data transformation and why I did this. 1 second. Yeah. So I'll just go to transform data. As we had mentioned that this thing is called query editor. This is the most important and the most powerful thing in Power BI. It's called Power Query Editor. So in the last session, we talked about how to get the data. Then we talked about how to transform that, how to remove columns and remove rows. So this is the table that we worked on. We changed their names. We grouped them into different groups for the sake of readability and intuition. We had renamed certain columns. We had trimmed the text. We had changed the types of the columns. You can just click here and you can change the types from here. We have so many different types. Then we also talked about the M code, how to read this and how to make changes within the M code. We also talked about how we can replace values, right? And how we can split the column by a delimiter, or let's say by any number of characters. What I want to talk today about is merging the queries. This is why I explained to you joins, because that's a prerequisite, or let's say that you need to understand that concept to move to merge. And then we talk about append queries. So these are very important concepts that you need to know when you have multiple tables and you want to just have one table in your data model, or you want to create a star schema in your data model. So this is really important. We had also talked about using first row as headers, and then in the transform we talked about how we can replace values again. You can transpose, you can pretty much do anything. You can format, you can split the columns, you can extract values from a particular column. So in format we have trim, we have clean. What trim does is trim removes all the spaces before and after a word, a string or a number. What clean does is it also removes all the spaces that's even between a word. So let's say my name is Talha space Khan. If I perform clean, it will remove the space between Talha and Khan. So this is something that this does: add prefix, add suffix. So you have so many options in transform data, and you will get to these. So most of the times you won't even have to use so many. For most of the reports, if the data is good, you hardly use any. But in some cases, data is really complicated, and you have to use so many different transformations, so many different features and functionalities over here. We can also, when we can add columns, we can add a conditional column. So for example, you can add certain conditions. Let's say if you click on this and you say if, I'll just call it test. So kidding me. Let's say if the column name, if order quantity, let's say is greater than 10, then output should be, wow, so many orders, for example. Else, meh, yeah, I just write anything over here. So for example, if you look at this now, see, if the order quantity is less than 5, we added a condition, right? You can see in the M code as well. So if the order quantity is less than 10, sorry, it will say, wow. So greater than 10, it will say, wow, so many orders. Else, by else, what do we mean? So the condition here is greater than 10. Else would be the opposite of this, which means less than 10. So for less than 10, it will say meh, lol. So you can see over here, we only have these two conditions, right? We have wow, so many orders, and we have the other one. So you can create any condition based on your data model and requirements. You can do a lot of calculations over here. You can extract different integers, different values. You might have a campaign name field, for example, which might have 20, 30 different field names, right? And you might just want to extract, let's say, the model of a vehicle, and the campaign name is so long, you can use the conditional form, a conditional column, and you can add all those values. So I'll just go back here, I'll remove it. So this is everything that we discussed, right, in the previous session. Now, talking about appending queries. So I did import some data over here, just so that we don't waste time in this session. You all know already how to import the data. You just go to home and you click on new source and you get the data, whatever source you want. So now I have sales table. So I have a sales table that has data from 2014. Then I have sales from 2015, and I have sales from 2016. Now I'm just wondering, why do I need these three tables? If they're representing the same data, everything is the same, only the year is different. Why should I not just have one table with all the data from all these years, right? That's when you use the append query. What append query does is it combines these tables vertically, not on the sides, not like joins, just vertically, one below the other. But the main requirement for this is all the columns and the data types and the column name should be the same in each table. So if you look at this, just on a high level, see we have order name, order number, date, channel, etc., etc. Then for 15 we have the same. For 16 we have the same. If anything were different, it will not work properly. It will create errors. I'll show you what happens. So let me first just append them. So you go ahead, you click on append queries. There's three or more tables. You have two options, two tables or more than two tables. So in this case, we'll be having three tables in total. Click on this, press Control, click on this, add, and OK. So now you see we have in the same table, we have data not only from 2014, wait a second. We also have data from 2016 and 2015. Why? Because we appended them, right? You can see everything is the same because all these tables had the same columns and column names. Now, what happens if in one of the tables, let me just change this channel in this table to channel 2. What will happen in this case? So in this case, if you look here, a new field will be created by the name channel 2. And it's null for 2014 and 2016 tables. Why? Because this channel 2 does not exist in these two tables. It only exists in this table, right? So what happens is that for the channel field for 2015, we'll have all the nulls. Why? Because this Power BI does not know what channel means in this table. So if you look at null, you see all the values are from 2015. And similarly, in this case, for 2015, we have a new column that has the values here in channel 2. So it's very important to have the same names, same data types, and same everything if you want to append your table successfully. Now that we have appended them, what you normally should do is, I've already done that, but there's this option. If you left click, there's an option enable load. So now since you have all the tables here, so let's say sales overall. Now you have everything here. Now, if you want to close and apply and go to Power BI, you don't want all these tables, right? You only want one table. So what you will do is you will right click. I already have disabled it, but you disable this option. You don't want enable load. What enable load means that when it's enabled, this table will be in the Power BI model after you click on close and apply. But we don't want that. We only want sales overall. So let me just show you how this will work. Close and apply. Load now. On the right hand side, you should be able to see only one more table, which is sales overall. Here you go. You don't see 2015, you don't see 2016. I hope this makes sense to you. Now let's go back to it. Now this is explained, so I don't really need this. It was only for explanation. Now we talked about relationships, why I revised relationships, and why I talked about joins is for this reason. So we talked about lookup tables and the main table. This main table is called the fact table, where we have all the numbers and everything. These tables are called dimension tables, where we get more information about those numbers. For example, uh, we have a region, right? We have delivery region index, where we talked about one is London in the UK. So one is London in the UK. So we can have more information that one is London, it's in the UK, and this is the full name. You could have so many more options here. Uh, for example, you can have Shire, you can have different districts and different regions, continents, provinces, states, all of that. You can have a huge address table. But you see, there's a common value, there's a unique identifier, which is called index. You will only need this index in the sales table, because now Power BI will know that, okay, it says one. I have to go to this table and see what one means. This is what one means. So this is how it works, right? Similarly, for products, we have the product index, we have the product name, and in the sales table, we only have the product index, right? So now Power BI would know that which product is it that had, let's say, this amount of sales or revenue. It's product 12. So it will see what is the name of product 12. In this case, it's product 12, but it could be anything. It could be an airplane or a tank. So this is what lookup tables do, right? But in terms of analysis, sometimes we don't want to have so many tables, because analytical engines, they don't work so well on complex models, on so many dimension tables. They do when it's simple. But sometimes for our business case or for any reason, we just want one big table. I don't want customers table. I don't want products table. I don't want regions table. I only want sales table. I want to make it easy for myself. How will I do it? I will join these tables into this table. Now, how do we do that? Let me tell you how. So you click on this. You click on merge queries. Now, merge queries is another name for join. So you click on this. And what do I want to join here? We're talking about, first, let's talk about customer names. So this is the field. I talked about a common field, right? So this is that common field. We want to join this to customers table to this field, right? These are the common fields. I want to have a left join. Why I want to have a left join? Because it's a customer database. There could be 100 customers or 1,000 who have not purchased in these 3 years. Maybe they purchased in 2013 or maybe in 2018, but they are there in this table, right? So if I were to have a right join, I would have all their names with all the other rows would be blank. Only they would only be their names, because they have not placed any order in this table. So that's why I want to go with left join. So I get all the orders that actually exist and who was the customer for that order. I click on OK. Now I click on this expand. What are the fields that I need? I already have customer index, right? I don't have customer names, I don't have emails, so I remove customer index. I only have customer names and emails, and I click on OK. So now you can see for each customer index, for example, look at number one. This is for which customer index? This is for 59. So 59 is, or let's just look at an easier one. Number one. Who's number one? I'm number one. Number one is this geese company. So if you go to customers, you can see number one is geese company. So what it's done is it's brought all those records in this table itself. Now I don't need this table. So what I'll do is bye-bye. Okay, no problem. Now it's saying it will be broken. Why? Because we have used this table in the data model. We have used this table in our visuals. So this definitely will affect that. But I don't care about that, so I'll just remove it. Now again, we'll do the same with regions and the product. So let's just do real quick. So let's again click on merge queries. Let's click on customer name is done. Let's go to delete region index. Now we want this in the regions table. And this is the common field. Again, we'll do the left join. Press OK. What are the fields we want? We want everything but the index because we already have the index. I press OK. Amazing. Now we quickly do for products as well. So I want to have common products. It should be somewhere here. Then I go to the products table, index, left outer match, left match, sorry. It says left outer, it's the same thing because they're outer matches, they are not inner matches or not inner join. I don't need index, I need product name. Okay. Here you go. So now everything is here. I don't need this table. I have all the data in one table. I don't need this table. I'll just remove the load. Now you might have noticed one thing as well, that there is enable fresh. Why do you always want to keep this on? Let's say if your data was updated, if your data was connected to some database and this data was getting updated daily. If this was disabled, let's say if 1,000 new cities or 1,000 new places were added in this table in the database, it will not be refreshed over here. While you want to refresh it, you just don't want in the model. So make sure that you always keep this in the report refresh. So now let's go to sales and let's rename these because I see there's some issue in the names. Yes, now it's taking the table name and then the column name. So we don't need the table name. Let's just remove this. Let's remove this. Now in the previous session, I talked about why we want to have the same type of transformation in one single step so that you don't get so many new entries for each change. So here we have regions and then city, then we just need country, and we need region. I'd like to have got a region name. I'd like to just call it product name. All right, we're good. I hope this makes things very clear for you in terms of what we can do in merge queries, append queries. So close and apply. Now let's see what breaks over here. Probably this will break because this product did not exist in, you see, yeah, because this name was not available in this table before. So now we just need to, instead of product name over here, just put the product name from over here. And it's working. Similarly, what does it say? We see total product. So now total product, we were taking the product name from the product table. We just want to go here and click on sales. Product name. Is the product name? Let's have product index, just the same thing. It should be product name. It doesn't matter actually because it's count. If it was distinct count, it would have mattered a lot. Distinct only finds the distinct values without duplicates. So for example, we have only 12 products, right? Here is counting each and every row in the table. If we had applied distinct count, it would only give you 12. Why? Because we have only 12 unique products. Are you kidding me? Yeah, 15, sorry. We have only 15 distinct products. But we don't want to know distinct over here. We just want to know, wait, this needs to be distinct. What happened over here? Anyways, this is fixed now. This needs to be distinct. But if you want to see total, let's say number of rows, you use count. If you need to see total distinct number of products, Even if they were sold 10 million times, you just need to select distinct values, you apply distinct count. We also created some very simple measures, like total items, you sum, you count, distinct count, sum x and of the revenue. So now we also talk about difference between sum x, it's called a iterative function, versus just sum. It's a normal aggregation function. Today I want to talk about calculate and what's calculate and why it's so important, why it's one of the most important functions. So let's say I want to calculate sales. Right, so let's say sales is calculate what its total revenue. So I just name it revenue. No, one very important thing is that what is calculate? Calculate is basically it's a measure that changes the context of a measure. Now, what's a context? No measure can work without a context. In this case, we created a measure called total revenue. Right here also we have total revenue. It's the same measure, but why are there different values? Because measures work with context. In this case, the context is the product. So in the context of product 6 generated 11 million sales or revenue. Product 10 generated 10.7. But in this case, the context is the year. So the context has changed now, right? In this case, the context is product. In this case, the context is year. So in 2015, we had 59 million revenue or sales. So measures only work with context. Without context, measures cannot exist. So now this is in the overall context, everything combined. That's also context. So for measures, it's really important to have a context. Without context, measures can't really work. Something's wrong with my ear now. All right, so now moving forward, we want to talk about calculate and why it's so important. Calculate is used to change the context of a measure. And in calculate, you basically need measures to start. So that's why measures are so important. You can't just write revenue and you can see in IntelliSense, this revenue is not appearing, right? Whereas when we're creating a simple measure, sum, we selected this revenue to calculate the total revenue. But in calculate, it needs to be a measure. So we take total revenue, but now we want to change the context. So let's change the context to, okay, let's say I want to calculate only for, okay, so the first thing is the expression, the second is the filter. So now this is the new context. After the comma, we define a new context. So the new context is I want sales only for the product name, right? So for the product name or for product description index greater than 3 and product description index smaller than 8, right? So now what this ampersand means, it means and. So you're saying I have two conditions. Condition 1 is that it should be greater than 3 and less than 8. So it should be 4, 5, 6, 7. Wherever the product index is 4, 5, 6, 7, calculate the revenue for me. Ignore everything else. You press enter. So now you take this table, you take the product name. Where's the product name? Am I blind or what? And then you take this total sales. See, it's only showing you for whatever condition we had. And the condition was, as you can see over here, greater than 3, which is 4, 5, 6, 7, and less than 8. So now in this, what we have done is we have changed the context of this. Even though these two tables are the same. For example, I am dragging the product name. Here too, I am dragging the product name. I am dragging the sales. This is not a table, by the way. Sorry, this is a bar chart. I am dragging this new measure in which the context has changed. If I were to drag this over here, now you can see in the first case, it's showing only what I calculated now in a different context. Whereas where we had not applied any context changes, it's calculating for this context, which is the product name. I have not specified here that I don't want for these other products, right? So this is one of the ways you can calculate. You can use calculate function. It's really important because in calculate, you can apply so many different conditions. You can apply 10 more conditions over here, 10 more filters over here. You can use multiple measures within the calculate function. That's why it's always important to create these measures. You could have used this revenue and just drag directly to this chart and it will show. But I created a measure so I can use this within other measures, right? So I can branch or I can sub branch the measures. It's called branching out. So now we understand calculate what it means. I also want to talk about something which is really important to me, which is the formatting. How do we format the stacks? Now, this looks so hard to read, and if there were like 2, 3 more conditions, it would be very uncomfortable to understand for someone new or even for me. So what I like to do always is I like to format them. Just press Shift Enter. So right, so I with each formula, with each new uh, function, I just press Shift Enter and indent them. So now this is much easier for me to read, right? So I know first I have calculate, then I have sales, then I do filters. Or I can even make it easier and I can just press Shift Enter over here as well. And now I know they're all right. So first I have calculate, then I have this. Khalas. Good, easy, simple, done. Let me also explain to you one more thing, which is called filter. Now this is filter, we were filtering it, right? We can also filter it another way. Let's say it's the same thing because calculate uses the function filter. So I am filtering my data based on this condition. I'm saying filter returns a table. It returns a virtual table. So what's doing is I'm saying, okay, only in the sales table, remove all the other rows, only give me the rows in which product index is greater than 3 and less than 8. So it will remove all the other rows and it will only give you those rows. And then you can apply, and then it's going to calculate total revenue for only those rows. It's the same thing, but it just makes your function a lot more flexible. For example, now what I want to do is I also want to add one more condition. Okay, what's happening? Apply one more filter, which is sometimes Power BI just does not understand what to do. So I just press a get tab, right? I apply one more filter. Why is it filters? I also want to know that the channel, where's the channel? We had a channel here, right? Or we had channel, yeah. So I also want to filter the channel. I only want to have the sales where the channel was sport. Right, so now I just this works for me better. So I just like to create just new function and a new run indent. So now I have one more. This is missing. I press enter. It should work. Filter mission. What's happening here? This should work. Sorry, here I forgot to apply the sales. Yeah, because I just first you need to select the table, yeah. And yeah. Now you can see I've created this table, right? There's this measure. So I'm just creating this to explain to you why DAX formatting is so important. Let me just call it DAX formatting. Now it's so much easier to read as it was before. So if you have such complex queries, it's always awesome DAX expressions. You always have to format them in a way that's easier for you to read. Now let's talk about one more concept, which is called variable. Now variable is a very important concept because it makes your life much easier in terms of very complex functions or complex DAX queries. So variable is defined by using the word var. Now just understand this is not global. It means whatever variable you create in this measure will only be limited to this measure. As of right now, you can't use that variable in some other measure. So let's say I create a variable called uh, product min. So product minimum product that I want to have is 3, the minimum index of the product, right? And then let's say I create another variable called product max. Now remember, you can't have spaces in this. So that is, let's say, 8. So now here instead, so you also have to add return over here. So here instead of this, You see this over here, right? So now instead of this, we can use the var product min. See, here it is. And you can use here the var product max. It will give the same result to you. Why? And why it's important to use? Because sometimes you might have to use this product min or max 10 times in this DAX, right? So all you have to do is just go here and just change it over here instead of changing it everywhere. And it just makes your life so much easier. In fact, we can also use this entirely as you know as a variable. So let's say I want to call it var. Let me just call it product filter. Right, so I add over here. So here what I'll do is I'll just remove this and I'll say, okay, use product filter. So this is so dynamic and so flexible that you can use anything. You can use different formulas and functions within a variable, and then you can just call that variable over here and just run the function. Similarly, you can use this as a variable. Just copy paste to over here and just let's call it var channel is equal to this, and then here you just need to call it. Something's wrong over here. Yeah, let me fix channel. Yeah, there you go. So now it's so simple. So if you have sometimes, if you have to reuse this in nested queries, in nested DAX, if you use these multiple times, it's always better to just ignore that and just use this instead. Use this approach of variables. Also, you can, there's one very important thing to called comment. So if you use this, right, or this, let's say, wait a second, if in any row, if you use this double back or backslash, you can add a comment. Here I am calculating XYZ. Now this comment will not be part, so now your query will not be affected. It's only for you or for someone else to come back and see what exactly happened here, what's happening on each row, or what's happening overall at the end of this query. So I am calling the variable here, for example, right? Calling another variable here. So now these comments can make your life so much easier and they won't affect your query. Just remember to add double slash backslash, otherwise it will be considered as a part of the query. Press enter and it will not give me any error, as you can see. So this is why it's very important to have this formatting in place, to start using variables and to start commenting stuff for yourself and for anyone else. All right. All right, now here we go. So I also want to talk about what's next on the agenda. We talked about formatting, we talked about calculate, we talked about joins, we talked about comments. Let's talk about time intelligence functions. All right, so let me delete this. Let me go to a new page. So I already have created a table over here, so we can just start. All I have done is just drag the revenue and drag the date. What is time intelligence function? Now, whenever you're doing some analysis or whenever you're working on any report, it's always so important to compare things in time. It doesn't make sense to just say, hey, I have 1 million sales this month. All right, so what? Is that a good thing? Is that a bad thing? How many sales you had last month or same month last year? What are the benchmarks you're comparing this with? What's the relation to how good your performance is? Maybe having 1 million sales is the worst performance we've had in the past 50 years. So you always need those comparisons in time, in different in different time ranges, in quarters, in months, in years, in weeks, or in days. So Power BI has an amazing capability which is called time intelligence functions. So I'll just explain to you what that they are. So let's say I want to calculate the sales in the last year, right? So how do I compare sales in this year versus sales in last year? LY means last year. I'll just here write it for the sake of simplicity. So calculate, right? So I'll now what I'm doing with calculate is I'm using this to change the context, to change the context of the measure. So I take this and why does it always come? So what I want to do there is there's a function called same period last year, as you can see. What I'm doing is I'm saying that now same period last year, it returns a set of dates from the previous year. So if we have 2014 here, it will return 2013 here for the same day. Similarly, 2 June 2014, it will say 2 June 2013. That's what it does. Now in calculate, we know that how calculate works is it changes the context. So what's calculate doing here right now? You can see. So I'm saying that calculate total revenue, right? But for these dates. Now what are these dates? These dates are the previous year's date. So this is how calculate works. Calculate XYZ metric, but for this context, this condition, this filter, I press enter. Now let me show you the magic. So now just drag and drop, and you can see here it's empty. Don't think I've done something wrong. It's because we don't have data for 2013. So if you go down and you go to 2015, you'll start seeing the data. And just look at this one value. It says for 1st June 2015, we have revenue of 110,000. But it's saying for 1st June of 2014, we had revenue of 108,000. So if you go to the top, it should match. You see, it's 108,446. It's the same thing. Now this is how it works, right? So you can calculate same period last year, and there's so many other options you can calculate. Let's say, how would you calculate all the sales from month to date? What's month to date? Today is 2nd June. Let me give another example. Let's assume today is 15th of May. So you want to see all the sales that were from 1st of May to 15th of May combined, cumulative. That's called month to date. So whatever date it is in this filter, right? It will calculate for that entire month until that date. So if you talk about 7th of June, it will calculate all the sales from 1st of June to 7th of June. Here from 1st of June to 8th of June. That's called month to date. Let's clear that real quick. So let's say we want sales MTD is month to date is equal to calculate. Now, what I like to do is revenue, right? We're using the word revenue, total revenue. No, not yeah. So you can have dates MTD. This is one way to do it. You just use dates MTD. Okay, let's just do that. Date. Now look at this. Here we are sales on the 1st of June for month to date. So of course, it's just one day. On 2nd, it's 1st plus 2nd. On 3rd, it's 1st plus 2nd plus 3rd, and so on. And you see, after the end of June, it restarts in July, because right now in July only one day has passed. Now 2 days have passed, so it will just keep calculating like that. So it gives you cumulative sales for that particular month. But there's also another way of calculating all of this, which is my preferred way. And it's a very powerful function, very flexible function on Power BI, which is called date add. So let's say I want to calculate sales previous quarter. I'll just call it PQ. So what I'll do is I'll calculate sales, not sales, that is revenue. Right now I want to change the context of revenue. There's a function called date add. What date add does is, see in IntelliSense, it's saying it basically, wait a second, it's not telling me about date add. It moves the given set of dates by a specified interval. So you have dates, interval, and interval. I'll tell you what that means. So I want to change the context of the date. So what I want to do is, I want to see in the previous quarter, right? So you specify the interval over here. Interval is -1, because it's previous quarter. And what is the interval? That's the number of intervals. So if you want to go 3 quarters before, you write -3. If you want to go 5 years back, you write -5. Let's say sales 5 years ago as compared to today, or sales 3 months ago. You just write that number, and then you specify the interval. So interval I want is quarter. So now what it's doing is calculating the revenue in a new context. That new context is the dates, but of the previous quarter. You press enter, and you can see. I hope it works. You gotta be kidding me. More than one column was whispered. So yeah, it has to be the date column. I selected table instead of the column. You have to select a column over here, the date column. So now you just move it over here. So again, for 2014, we did not have until November. We did not have a previous quarter. It's 3 months, right? So June, July, August. We start with September. So it's giving you again the sales of the previous quarter. So in the case of 1st of September, the previous quarter was 3 months ago, which is 1st of June. It's giving 108,000, and if you look at 1st of June, it's 108,000. So this is what these time intelligence functions do, and they're so useful, and you can combine them. Let's say you find sales of this year or sales of this month versus sales of previous month, and just you subtract them. You subtract them, you'll get month over month change, right? And similarly, you could go year over year change, quarter over quarter change, and these things are so important to do because if you're just giving these numbers over here without context, 8,000 orders, so what? 8,000 orders, and here you attach, let's say you add plus 5% from previous month or plus 30% compared to previous year. That's the context we want to give. That's what we mean when we say context. 8,000 in itself means nothing. So I just want to keep this short. We already are 51 minutes in. It's already very long, but I hope this gives you a nice idea of calculate of how to DAX your or how to format your DAX query, how to DAX your format, how to format your DAX query, how to use comments, how to use calculate, how to use time intelligence functions, and then just a few best practices for this. For example, you just can keep all these cards here on the right, on the left, make it very minimal. Make sure that you have the labels. You have a nice title over here that's very self-explanatory. Now, this all looks all right, but what if someone wants to drill down, right? What if someone wants to have some options to look at back to see by countries and all of that? This is very basic. So one very important thing is slicers. Use this to slice and dice the data. So let's say I want to see all of this information, but for particular regions. So I just go here and I just select the country. Sorry, I'm on the wrong screen. Now, there's one ways to have it like this. I'm not really a fan of this. What I like to do is go to the formatting, slicer settings, and take a drop down. That's what I like to do. So now you have this filter over here by the name of country. And you know what? Let me just go to view and click to page. I had only zoomed in for you to be able to see clearly. So you can just see any country. So I want with Belarus, and this is the data only for Belarus. I can press Control and select multiple countries. So this data will be changed accordingly for those countries. I can go here and click on play. You can always change the colors and everything. You can go here, you can go to slicers, let's say settings. If you want to have multi-selection on, if you want to have select all or not. So if I press select all, here it will say select all. If I remove this, it does not show select all. Similarly, in the header, what font color you want, do you want a border, do you want a background? Play with all these things. They're very simple and straightforward, depending on the color that you want. And about colors, you can always go here and you can just try these random themes. They're so easy. You can just click on it and see the entire theme changes except for this, because this is a shape that I added myself. But you can just change the themes over here in Power BI itself. I'd like to go back to the one that was before, yeah. Now I see here it looks really bad because we have a white background for this. I don't like white background, so I'll just go effects and I'll just remove the background. You can also have a filter for product. So I'll just create a copy of this because we have formatted this. So let's say here instead of this, I'll just take the product name. So I'll just drag and drop on top of this. I don't know, country, product name. And then do I also want by customer? No, not really. I don't want by customer. So now you see it looks right nice, right? There are 15 products over here, and I want to explain something to you guys. So I just take a copy of this, and I want to see top spending customers, right? Or let's say most valuable customers. So instead of product, I'll just go to customer name, customer. But now just look at this. Who on earth is going to go through all these 300 records? No one cares about that. No one, honestly, no one gives two pieces of sensor about this. But see, what you ideally want to do is you want to make it valuable for someone, right? I want to know who are my top customers. By top, I will care to define that. I want to see top five. So you go to filter pane, go to top n. Let's say I want to see top. Give me the top seven. Top seven customers based on what? Based on their sales or the revenue that they're bringing in. Apply. So now you see it's only top seven. Just check this out. It's top seven is so much easier. You don't. No one really has to go down and look at all the 500 customer names and try to get some insights from that. So you need to keep it very brief and short, and you need to keep it to the point and only what you feel the stakeholders will want to know. Similarly, you can do it for this as well. And also, once you have this, I'll just remove this for sake of explaining one thing. There's a thing called conditional formatting. You see, it does not really make sense to just scroll down and see all the bars are just decreasing. But how do we make it more intuitive for someone to understand? Let's just go here, go to the bars. You can always change color. Wait, first I'll go and I'll just copy this hex code. Hex code is a 6-digit unique code for each color. I'll go to this format. Now you have different options, right? So what I'm saying is I want a gradient. You can have rules, you can have something else as well. So I'm saying I want a gradient if my value is the highest, I want this color. But if it's lowest, I want a much lower color. So let me just go and more colors, make it wider and much lighter. And based on what field value? Again, it's based on revenue. Okay. If you look at this, I don't like to see this legend over here, so I'll just say no, off, turn off the legend. Now you look at this carefully. If you keep scrolling down, as the revenues are decreasing, their color is also becoming lighter, right? So this way it's much easier for the stakeholders and another way of showing or visualizing things. So it depends on your requirements, but this is a practice that I like to adopt. So I'll just again go to back 7 and total revenue. You see here, the this might not be the best color right now because of the background, but you get the point. Ignore the colors. You can always use better colors, or in fact, let's do it. Why is it not working? Yeah, why is it not working for this? Because I've specified the color in the conditional formatting that you need to use this color. So let's just go back to, yeah. So similarly, you can do it for this. You can add all the filters over here to drill down and to get into more details and nitty-gritty of this. Now, I won't spend much time in the beautification of this report. There's so many things we can do. But first, I want all of you to go and try this and test this and see what things you can find. We'll have another session soon, and in that session, I want to show how you can make your reports extremely beautiful in terms of UI and much easier to use and navigate. Make it more like a computer program or a cool website where you have these different things popping out and you have different filters and slicers and different tabs. So that will be much easier for you to understand after you've practiced a little bit. So I think we're in a very good position right now, and we have covered quite a lot. So now you can proudly call yourselves, if you followed everything, you can create an intermediate report. You can create a really nice report for your stakeholders, and they'll be really happy with you. To go to the advanced level, we'll have some more sessions, inshallah, soon. But for now, I think this is it for Power BI. Before we finish this off, I have some very important suggestions for all of you, the best practices and the don'ts. Listen very carefully. Number one, you need to understand your data and your audience. I posted on LinkedIn about this as well just today, in the morning. You can't just go and start creating a report. Hey, cool, let's create a sales report. Fine, okay, let me start. I did not consider that right now because I'm trying to train you guys on what Power BI is, how to use it. But whenever you create a report, you need to understand your audience and your data. What are the key messages that you want to convey? What are the business problems that you want to solve? What are the business questions that your stakeholders want answers to, right? What is it that your audience really know, and what is that's the most important to them? For this, it's always best to have some industry knowledge or some business knowledge that you're working on. You can't be an amazing data analyst without having a business acumen. So it's very important whenever you start a data analytics project, take a pen and a paper, write all the goals, understand your audiences, step in their shoes, and see what they want. Second is keeping it simple. You might have seen on LinkedIn as well, so many people post on different groups with visual with Power BI screenshots, 50 visuals in in one tab. It gives me headache and maybe some other problems as well, but mostly headache. You don't need to do that. If there's so many visuals, are your stakeholders going to think, what do I look at? Or are they actually going to get insights from that? So you always need to keep it very simple, make it very, very, very straightforward. Remove any clutter. There should be no complexity. And if you think any value, any visual, any card, any chart is not adding any value, just remove it. You don't need to show something just for the sake of showing it. It needs to give some value, some answer, or it needs to solve some problem. And then use consistent design. Now you can see here I've used red color and I've used a colon at the end. Don't do that. If you're using different charts, use the same kind of fonts, use the same kind of colors, keep the same consistency. This will make your report look professional. Keep the same font sizes for headings and the same font sizes for X's, same font sizes for whatever you are writing anywhere for context. But always pay attention to the design and always make sure that there's consistency. You also need to highlight key points. If there's some good message that you want to convey or an insight, make it very obvious for the user to understand that, hey, sales this month have increased by 300%. Highlight that, make it bigger, or but just give it some color, or just make sure that you add text box and say, hey, our sales have increased by 300%. That's something to be proud of, to shout about. And then you later go into why. Also, you need to provide context. Here again, I have used inconsistency in design. I have again used colons, which is bad. Again, as I mentioned in the session earlier, you need to provide context. You can say, well, we had these many sales or these many new customers this month. So what? So what? Is that a good thing? Is that a bad thing? In what context did you have these customers? How many did we have last month? So you had 10,000 this month and we had 50,000 last month. So you have not done good this month. You've actually done bad this month. So you need to give that context, what's happening. You can give context in terms of anything, right? You can give context in terms of benchmarks, in terms of time, like we use time intelligence functions, or you can just give context by creating a text box and typing everything you know about that particular measure or that chart, what's happening in that chart. So it's really important to provide context. Without context, your data means nothing. It's just useless. It's 100% useless. What are things you want to avoid in each and every report that you do? Again, it's the opposite of what I said in the previous slide. I'm just reiterating what I said. Do not overload information. Just put only enough information so it's that sweet spot where it's insightful for the stakeholder but not overwhelming. If you tell them each and everything that has happened and they're like, okay, what the hell? I don't even understand where to begin with now. So just provide enough information for those specific stakeholders. You don't want to have the same report for your CEOs that you have for the managers. You don't want to have the same report for the managers that you have for the performance executives, people who run the campaigns. You don't want to have it same for the people who actually, let's say, make the platforms, the developers. So it always needs to be as per your audiences. No, just let me give you an example. So instead of showing, we talked about this just now, you show 100 products, sorry, in a single chart. Why is it even necessary? You just show top 10 products or the bottom or the least performing products, right? It will just make your charts and so much simpler and so much prettier. Do not use inappropriate chart types. Well, anything inappropriate is not good, but especially charts. Don't use the wrong charts. For example, you can't use pie charts to show trends over time. You need to use a time series chart or a line chart to show trends over time, because trends have to be on the x-axis. I mean, the time has to be on the x-axis. You can't use pie chart or let's say a tree map for that or a donut chart. So always use right charts if you want to convey the right message. Do not forget to label. Whatever charts you create, you need to have access on that. I don't mean your X, I mean axis, AXIS, X axis and Y axis. You need to have that. You need to tell, okay, in which context is this your X axis? For example, let's say you have not labeled X axis and you showing sales over time. Now, what is this? What's the context? What is this time? Is it in weeks, days, months, years, decades, centuries, double centuries? What's the context of this time? Also, do not mislead with scale. For example, when you create these bar charts, I've seen so many times people start their bar charts with 20, 30, or 40, right? So your chart starts with 40, and it gives a very wrong impression to the stakeholders that maybe the performance is really bad, or we're trying to exaggerate the performance. You always need to start your axis at zero. The y-axis should always be zero instead of 10, 20, 30, 50, 100. And always use the same scale for all your charts. It's not like you use 50 for one chart and then zero for other chart. So try your best to use that to just one single scale for your access. Now, until we meet again, what I want you to do is create two Power BI reports based on the sessions that we had. I've given you a data set. Get some other data set from Kaggle. Create two reports. Follow all the things that we talked about. Know your audiences. Know your stakeholders. Know the problems that you want to solve. Follow the process of data analysis, that is data collection, which you already have, data transformation, data standardization, data modeling, data visualization, and then insights and recommendations. Make at least two reports, because maybe probably in a month we'll have some advanced Power BI sessions. So I want all of you to be on the same page when we start that. And in the meantime, read about what is SQL and what are databases, just basics. Because in the next sessions, we're going to talk about databases, data warehouses, data modeling, uh, more on into relationships, nothing to do with your access again. I mean, entity relationship diagrams, and about how to create a basic database. So again, what I just said now, I'll reiterate that. This is what next session will be. This was the last Power BI session for now, because I believe you guys are well set up. If you followed it properly, you're set up really well to create a very decent report, visually and also in terms of data modeling and structure. So kudos to you guys, and you're welcome. No, just kidding. And before you go, again, I requested this last time as well. I would like to request this again. This is an Instagram page of a brand that me and my friends are working on. So I'd really appreciate if you could just scan this on your mobile right now, go to Instagram, follow it, and share it. It would mean a lot to me. And yes, I think that's it. And thank you so much for listening to my TED talk and my pep talk and my boring session. But I hope this was useful. And I'm looking forward to connect with you guys very soon again. See you and Assalamu alaikum.